Hello, how are you doing? I'm Frank Carbone, specialist for the West region of ReadyArc. We're going to kick off this online training program with some information on TIG welding. TIG stands for tungsten inert gas. You'll also hear it called GTAW, which is gas tungsten arc welding. That is the designation that the AWS, the American Welding Society, uses as their official term. A brief history on GTAW or TIG. A man by the name of Russell Meredith with Northrop Aircraft in 1941 perfected it. He called it heliarc, and you'll still hear that term used today. He called it heliarc because his shielding gas he used was helium, and it was an arc welding process. Today, the vast majority of times the shielding gas is going to be straight argon. There are exceptions, there are different applications where different gases or mixes are used, but argon is going to be your primary gas. There are advantages and disadvantages or limitations on anything. One of the greatest advantages of TIG is it can weld just about any metal. It was primarily designed for thin metals. You can do heavier metals if you have enough amperage in your power source. You can weld two different ways, one where you're using filler metal and one where you're just fusing the two metals together without adding anything. That fusion only is another name for that is an autogenous weld. One of the limitations or disadvantages is it is a welding application that takes a lot of experience and training on. A lot of manual dexterity, especially if you are using filler metal, because you'll be holding the torch with one hand and feeding the filler metal in with the other hand. And many times having to control the heat with a foot pedal as you're welding. So it takes some experience, and it's also a gas process, and being a gas process, it's not used very well outdoors unless you're shielded from the wind, any type of atmosphere pushing the gas around. So you do have to be careful of that. The power source that you use with it is going to be a constant current power source. That's also the same type of power source that's used for stick welding. The main difference between a welder that's used only for stick welding and one that's used for stick or TIG is that for TIG there are circuits in there for the start of the weld. With a stick, you just scratch the stick and initiate the arc, and you're off and running. You can do that with TIG. However, you'll get small amounts of tungsten into the weld puddle. And if you're doing code work, it's gonna show up on X-rays, and you'll have to redo the weld. So they have a high frequency start, which has been the most common, and for the DC welding, because you could do DC or AC, and we'll get into that in a moment. For the DC, it only is at the start. That's why they call it a high frequency start. With the AC, it generally runs the whole time that the weld is going. And I'll explain why a little bit later. There's also a touch start or lift arc. Miller calls theirs lift arc, and Lincoln Electric calls theirs touch start. When I was in engineering with Lincoln back in the mid-90s, I actually designed the touch start circuit for Lincoln Electric, and they're still using it today. They both primarily, the Lincoln and the Miller, work very similar in function. With the Lincoln, I know specifically because I designed it, the voltage is held at a very low voltage. It was around the 7, 8, 9 volt area, and the current was limited extremely low in the milliamp range. This is so that there be no arc possible. And what you do is you touch the tungsten right to the base metal that you're going to weld, and that signals to the power source that you've touched. Once you've touched, the moment you lift off, the arc starts. And if you accidentally lift off and touch again, you're going to weld the tungsten to the base metal, and then you're going to have to take out your tungsten and regrind it or whatever, so be careful of that. But anyways, they're both the lift arc and the touch start are nice because high frequency sometimes can interfere with electronic equipment in the area, computers and other sensitive equipment. So that's one of the reasons why the touch start works. It's not for AC, it's only for DC, but it does work very nicely. On the power source, you're going to have A polarity switch. The polarity switch is going to allow you to go either in DC negative, DC positive, or AC. Now, some power sources don't have AC, so it'll just be DC positive or DC negative. There are power sources that have no switch, and then you just have to physically swap the cables around. When you're doing TIG welding, the AC is used primarily for aluminum. Sometimes you could use it for magnesium too. Easy way to remember that it is for aluminum is AC starts with A, aluminum starts with A, so make the connection. Pretty much everything else you use DC negative. There are some DC positive applications, and we'll get into that in another course where we have time to talk specifically about that. Most of the time it's going to be DC negative. I will say this, if a customer calls you and says, my tungsten is glowing, what's wrong? Something's wrong with the power source. They probably have it in DC positive. Tell them to switch it to negative. DC negative, the greatest amount of heat is in the base metal. It's usually roughly a 70-30 split. It could be different, but that's kind of the rule of thumb. When you're doing that, you get a greater deposition rate. The DC positive, the majority of the heat is in the electrode itself, and not the base metal. Obviously, there's still enough heat in the base metal to do the weld, but more heat is in the electrode, and that's why if you're in DC positive and if your electrode is undersized for what you're doing, it's going to glow. In stick welding, a lot of stick welding is done in DC positive, and the reason for that is that the flux on the stick electrode is designed to burn properly at a specific heat level, and that heat level is attained by putting it in DC positive. Some of your flux core wires are usually a DC negative, and it's for the same reason. The flux that's inside of that wire will burn at a certain temperature properly, and the way the chemistry was designed on that, it worked better on DC negative. Now, some of your gas shielded flux cores run on DC positive, and again, for the same reason. It depends on how the flux was designed and why, and so on and so forth. In TIG welding, there is no flux in that manner like you have in those. But that is the reason that, power sources, sometimes you use them on negative, sometimes you use them on positive. And then, of course, because TIG welding, especially aluminum, you're going to use AC on many TIG welding systems, there is an AC selection. Now, again, not all power sources have it. So if somebody says that they're going to weld aluminum, you have to make sure that you are giving them a TIG welder that does have AC in it. There's also a thing called a wave balance. Now, what this is it's for AC, and what the wave balance does is when you have an AC signal, half of it is positive, half of it is negative, and this is happening so many times per second. Traditionally 60 times a second, but in inverters you can change that rate. 60 cycles normally, because that's what your wall socket frequency is 60 cycles per second. So if you have a wave balance feature on your power source, the wave balance allows you to give you more or less positive versus negative, so on and so forth. The positive when you're doing aluminum welding is used primarily for the cleaning action on the aluminum, cleaning any oxides or anything on it, and the negative side of the signal is giving you your deposition rate. So depending if you need more cleaning or more deposition, you would adjust that. And usually in most of them, there's one control, and it'll say let's say you set it for 30. That means that one side is going to be 30%. Obviously, the other side is going to be 70%. And usually you're adjusting the positive side, and the negative follows the opposite direction of what you did to the positive side. So positive, adjust it, negative follows it. Some power sources, it could be the other way around. Then you have an output control. The maximum output control, many of these have a pulse feature. If it has a pulse feature, that pulse feature is you have a peak current and you have a minimum current. So the maximum output, you're controlling where that peak current in the pulse would happen. If you don't have pulse, then that output control is just basically your amps, and that's that. But if you do have pulse, and you would have to control both the rate of the pulse itself, and you would do that with the pulse TIG control, and you would have to adjust where your peak currents are, where your background currents are, and the width and timing of the pulse, and you adjust all that with these controls on the machine. And there is no right or wrong. It depends on what you're doing, and the welder just has to determine what timing, what frequency of the pulse, what peak and background currents. A rule of thumb on the current is that the peak current is equivalent to the decimal size of the metal. So in other words, let's say you're welding 1/8 inch, which is 0.125 inch. So you would start at about 125 amps. So that would be, one rule of thumb that you can use. There's also controls for the gas. Some have pre-flow, some have post-flow, some have both. The pre-flow is going to be the amount of time that the gas runs before the arc is initiated. And this is to blow away any atmosphere around the puddle that will be there in a moment, and to get it shielded ahead of time. And the post-flow is the amount of time that the gas flows after the weld stops. This is so that you can continue to protect the puddle while it's cooling down, until the glowing goes away. Adequate shielding gas post-flow keeps the tungsten shiny also. If it's dark blue or purple, the tungsten, that means that you didn't have enough post-flow. If you see the tungsten changing drastically in color like that. So I'd like to have some further of these types of trainings, and I'll explain more on, like, for example, why the AC is going the high frequency is going during the AC welding, and a little bit more on some of just the technical things that we were talking about. So this is the first installment, and I hope you enjoyed it, and look forward to seeing you again soon.